Module 26, Permutations and Combinations, Section 2, Combinations. So what is combination here? Combination is a selection of all or part of a set of objects without regard to the order in which the objects are selected. So the order doesn't matter in the case of combination, but order matter in the case of permutations. So combinations are where the order does not matter. So for combinations without repetitions, again just like in the case of permutation, there are two formulas. If you do not allow any repetition, then the formula is almost identical to the permutation formula. So as we know, permutation formula was n factorial divided by n minus r factorial. Combination formula is n factorial divided by n minus r factorial multiplied by r factorial, just that r factorial is extra. So NCR, the other one is called NPR because that is permutation. Here it is combination. So the NCR is also known as binomial coefficient because that is also used in our binomial equation, which we already seen that. So the same combination formula is being used here, in the binomial as well as for solving for the combination problems. So for combinations with repetition, the formula is little bit tricky, but still is intuitive. So it is n plus r minus 1 CR, that is the beauty of it, is equal to n plus r minus 1 factorial divided by n minus 1 factorial multiplied by r factorial. So that is the formula of this with repetitions. The first example here is that 5 students are in the class and they are going for a conference. So determine how many ways the students can be chosen. So how many students can be chosen if they are going for a conference. So if the order matter or not, that is our fundamental question here. So here the order doesn't matter, so it is basically a combination problem. So repetitions are allowed, the same student can go as a 5 students. No, it is not possible. So it's only 3 students and all have to be different students. It is combination problem. And it is basically NCR is equal to n factorial divided by n to the n minus r factorial multiplied by the r factorial. So out of 5 you are choosing 3 students, So out of 5 students in the class, 3 are going for the conference. So you can substitute and to solve the problem to get 10 as the answer. So it is a very simple problem. The next example here is a special type of password consists of 4 different letters of the alphabets, where each of the letter is used only once. How many different possible passwords are there? So in this case, of course it is password, and that is not a combination problem, it has to be a permutation problem. So you have to use permutation formula for solving this problem. So there are more examples here. The first one is how many ways can you choose 3 sampling locations out of 7 possible locations, which is definitely a combination problem. Next is how many ways 2 consecutive polypeptide positions can choose 2 different amino acids from a pool of 20 amino acids. So the polypeptide positions, well, here the order matters or not? Yes, order matter, because if the amino acids are different, it is inversed, then the coding polypeptide will be entirely different. So it is a permutation problem. So a lab has 8 pipettes and 5 microscopes. How many ways a student can choose 2 pipettes and 2 microscope for her experiment? Here is does the order matter or not? In this case, order do not matter. So in that, therefore it is basically a combination problem. So there are 6 persons standing and 3 seats are available. How many ways these persons can be seated? How many ways? So the first seat, second seat, third seat, or the person is in the middle. So that way it is basically a permutation problem because the order matters there. So you can solve it using the permutation equation. So you have 4 pants, 4 shirts and 4 jackets. How many ways can you choose 3 clothing? Here just 3 clothing, anything. So it's basically a combination problem because the order doesn't matter in this case. So that is why you just have to put the combination problem here. So here is a problem for combinations with repetitions. This is the problem. Ways to select 3 amino acids from 10 amino acids, repetitions are allowed. So here the order doesn't matter, so it's a combination problem. Now the amino acids can be repeated. So in this case definitely it's with repetitions are allowed here. So the formula is n plus r minus 1 multiplied by divided by n minus 1 multiplied by r factorial. So n plus r minus 1 factorial divided by n minus 1 factorial multiplied by r factorial. So you can plug into this equation to get the answer is 330. So that is how to solve this kind of equations, quite simple. Just substitute, but you can revise some of the tricks for solving working with the factorial, which I have explained in the accompanying the e-text. Please read that e-text as well. So another problem is that you have one box with rasgulla, one box with laddu and one box with gulab jamun. Each box contains 50 pieces. How many ways can you choose 5 sweets? So 5 sweet, that doesn't mean that it has to be all different sweets. No, you can just choose only 5 rasgulla, whatever you like. So it could be different or it could be same. So repetitions are allowed, and it's a combination problem, just like in the case of the fruit salad which I told you earlier. So here n is 3 and r is 5. You can put this into the combinations with repetitions are allowed, then you are going to get the answer as 21. So that is how you can solve it. Another problem, a fridge have 5 different types of beverage: sparkling water, fruity, Manza, Sprite and Coca-Cola. So each has 50 cans, every beverage have got 50 cans each. How many ways can you choose 15 beverage? So again, order doesn't matter, and 15 beverage means that if you like sparkling water, that is soda, just like me, I prefer the sparkling water. I would take all the sparkling water rather than going for cola or juice, So in that case, definitely it's repetitions are allowed, and it is a combination problem because the order doesn't matter here. So n is 5, r is 15. So the total number of ways is 3876. Another example here. There are 10 gymnosperms and 20 angiosperms in a locality. In how many ways can you choose 3 gymnosperms and 4 angiosperms for an experiment with repetitions are allowed? So this one has got 2 parts. First is out of 10 gymnosperms, you have to choose 3 gymnosperm the ways. It's a combination way. And out of 20 angiosperm, you have to choose 4 angiosperm, that is another one, and then you can just use of FCP, that is just multiply each other to get the total number of ways. So the first one is that for gymnosperm, n is 10, r is 3. So the same formula with repetitions, you can use it. For angiosperm, it is n is 20 and r is 4. Same combination with repetition formula, you can use it. So another examples include, you flip a coin and roll a die. How many possible outcomes are there? So in this case, fundamental counting principle, you can use it. The first event is flipping a coin, that is 2, while rolling a dice 6. So you just have to multiply. 2 multiplied by 6 is equal to 12 ways that can happen. Another one is how many ways can you draw 2 playing cards from the standard deck of 52 cards? So basically you are drawing the card, so that means the order matters, the first card and second card. So if you are drawing 2 playing card, then it's a permutation problem, and you can just substitute into that permutation with of course it is without any repetitions, because all cards are unique in the 52 card playing deck. There are 8 polymorphic sites in a gene. Each site is having 3 SNP variants. How many total genotypes are possible? You can easily use FCP for this matter, or you can use permutations with permutations with repetition you can use. That is n to the power r, you can use it. So in summary, a combination is a selection of all or part of a set of objects without regarding to the order in which the objects are selected. Thanks for watching, and I hope you had a great week, and all the modules have been covered of this week, and please read the accompanying e-text as well as accompanying further references section web links, and please read all the web link material, the PDF files, and also watch the accompanying YouTube videos as well, the suggested the web link videos, as well as a few TED Talks have also been linked up. So please watch TED Talks as well. So these are also quite interesting. And thanks for watching. Have a nice time.